Hey everyone, today I'm joined by Kelsey Hightower. He's a developer, author, father, and minimalist. You might know him from the Kubernetes community or his work as a principal engineer at Google. Thanks for joining me today.
Yo, happy to be here.
I'm really excited to dive into edge functions, and I know that you like to explain things based on the fundamentals. So I'm really excited to take a step back, look at those principles, and talk about how they're changing how we build for the web.
Yeah, so for those watching, my background is a backend engineer. I come from a world where you have a three-tier web app, front end, back end, and a database, and maybe a load balancer in between. So getting the taste of all this serverless edge functions and how the web front end is evolving is super interesting to me. So I'm looking forward to breaking down those fundamentals.
Awesome. Well, to kick things off, I would love to just talk conceptually about why the edge. Why are we moving more compute to the edge? I'd love to hear your take first, and then I'll kind of give my opinion on why we're moving more logic to the edge.
Yeah, so the space that I come from, containers or even serverless, in the cloud, we tend to think about regions and zones. So ideally, you get as close to the customer as you can, but typically you're still running out of a centralized data center. And for the most part, this works just fine for a lot of people. But when you think about use cases like gaming, for example, you really want that client, wherever the customer is, to be connecting super quick to the edge. Also in my world, the explosion of CDNs. As you think about the Netflix use case or you're serving images, you want those to be as close as the customer as well so they can render fast, load, and you're not pulling data across continents. So I think that's been our first taste. So for many people, why edge? And it's like, why edge for specific things? Some people are still comfortable with centralizing some of the logic, maybe your order management system or your company or customer profiles. I think a lot of that is still largely centralized, even though we've moved it closer to people at the continent level. But I think there's always been a case, at least in the last 15, 20 years, of moving static assets like videos and images to a CDN, which tends to have way more locations than our standard regions.
I love the 2 points you made about one, just trying to get content closer to users, but then also effectively using the right tool for the job. It's not that we're moving every single workload to the edge. It's another tool in our tool belt that's enabling us to build better applications for the web. I think when I look at why edge and just the landscape of web development in 2021, it seems like what appeared to be static for a lot of sites is actually kind of deceptively dynamic, because the requirements for personalization and experimentation kind of put us in this tough spot as developers where if you wanted to have dynamic, you might have to, especially with a global audience, you might end up with a slow application. And if you try to solve that, like solve the speed problem by making it static, well, now you lost the personalization or the dynamicism. So it's been difficult to get both. So where I view edge is kind of trying to solve both of those problems together, dynamic at the speed of static. And I think historically, your context about CDNs, when we went to the edge with edge networks or CDNs, we lost a lot of the abstractions that people coming from the server world, like Express middleware, right? We lost some of the control and flexibility there. So we're trying to bring that back with edge functions, and we're doing it through an abstraction called middleware. So it essentially allows you to run code before a request is processed. And then based on that request, you can modify the response with rewrites or redirects or headers, all that stuff. Trying to enable code over configuration and get closer access to that infra at the edge, like running as much compute at the edge as we can for specific use cases, like you mentioned.
Yeah, so the good news is I got to put my hands on it. And so the limited front end experience that I have comes back from like the PHP days, right? You would render as much as you could on the server side, and then you would send over, a bunch of other things that then may do a little bit, the jQuery days where you can kind of context switch based on limited information you had from the browser or maybe the user session. And so I looked at how some of these frameworks evolved over time. And I've always had this question, it's like, where do you put things like secrets or database connections? And it seemed like the industry had evolved to the point where you could have maybe individual components like the calendar widget or the stock ticker widget, but they always seem to talk all the way back to the back end, right? So you got as close to the customer on the front end, but then there would be parts of it that will still have to travel over long latency stretches to work. And I think what we tried to do then is solve the problem of async, right? They just kind of load at their own pace. Maybe you're getting some of that data from a cache if it's not really personalized for a user. And then I touched the kind of new stuff that you all are talking about with some of these edge functions. And so the first experience that I had there was like, this feels more like Ruby on Rails. So Ruby on Rails is this really powerful kind of convention over configuration framework where you could just, design your app in a certain way, lay out certain, folders and structures. And then when you built the app, it did all the right things in terms of rendering kind of this backend applications with the best practices. I think you all are trying to do that for front end and addressing some of these going all the way back to the central server by having parts of the application run in this new serverless edge computing platform where I kind of get both the best of both worlds without necessarily thinking about how I deploy each and wire them back up.
Yeah, I think I 100% agree with that. And I feel like it ties into this evolution of the traditional way we were building web applications and how we're trying to help bring developers on that journey to the future and bring them along with us as we enable and give these primitives to try to make it easier. So I would love to dive into this topic a little bit deeper because I really appreciate your experience and your context on some of this. I'll try to give my perspective as a front-end engineer and as somebody who doesn't have as much experience in the infra side, and I'm curious to see how it kind of compares against yours, because I know that you've spent time as a system administrator, you've been an advocate for Kubernetes, and because of that, you've moved along from manually configuring VMs, moving up the stack to Kubernetes. And I feel like when I've listened to you talk before about this, you try to root yourself in like the first principles of web development, right? Like it's important to understand we're fundamentally just writing software and it's going to run on a system somewhere. And the closer that system is to your users, ideally the better. And we touched on this a little bit before we started, but ideally you could have that system be the browser, right? That's as close as you could possibly get to the users, but it's not really practical to run all of your compute there. So in the front end world, from my perspective, React has essentially become like Linux. It's this open standard for building the web. And then you have Next.js, which is the most popular distro of using React. So an analogy I like for the backend folks is like when you're using Kubernetes, you might be using tools like Helm charts as an abstraction to define your infrastructure. So this is, for those not familiar, it's like infrastructure as code. And then you can develop and maintain your infra the same way that you would your code. But at the end of the day, those tools are just compiling down to like YAML, right? They're just making it easier. They're an abstraction layer on top. Edge functions, in my opinion, are very similar. They allow front-end developers, back-end developers to write JavaScript that ultimately just compiles down to some serverless compute that's running at the edge. I like to think of it as like infrastructure defined from code. So a little different than that traditional model. What do you think?
Yeah, so I think when I think about context is, if you think about the base principles of it, there's a database, your system of record. It has all the products and the prices of those products. And then your goal is to try to render a shopping experience to people that are using a web browser. So in that world, my server is going to say, hey, you hit this URL. I'm going to present to you a page with my entire catalog in it, and then you can browse around in that experience. I think the challenge is I need to render your shopping cart uniquely to you. So I'm going to have to go back to the server and tell the database what you've bought to make sure that my database and what you see in your browser are in sync. And I think that's been the traditional model that we went about doing this. Yeah, and so you're right. In the Kubernetes world, that backend application, I did a lot of work to give it a configuration file with the database username and password. So only that backend application could connect to the database. On the front end, there's a lot of work that goes into identifying who you are and then having your browser session pass back those credentials to my backend so that I know that I can look up data in my database and take actions on your behalf. I think now what we're talking about is moving some of this logic even closer to the edge. And now you get into some real tricky situations where I can't give you my database password in the browser. This would be a nightmare, and you could actually do anything on behalf of any user. So we know we can't go that far with things like database connections, right? So we got to move that one layer outside of the browser. Now, typically, That would be something like even a serverless platform like Lambda or Google Cloud Functions. That's one layer. And then at that point, you're just giving connection details to some API on behalf of that user. That all makes sense to me. But I think now what we're saying is, do we really need to go all the way back to even a serverless function or a container running in Kubernetes? Could things like how we process headers, like if you're coming from Australia and I might want to show you a different set of content, well, I can make that decision now in the edge, aka where the CDN traditionally sits. I think that's where it's going to get super interesting. And now I think as people coming from the front end or from the back end, we now have a decision to make. Where do we put this kind of logic and where does it make more sense?
So I'd love to pause here and to actually look at some code that kind of explains what you're talking about. How can we push authentication or logic closer to users, a layer back from the browser, and make that have lower latency in their requests? So let me share my screen and I'll pull up some code. So I know that you've had a chance to check out edge functions ahead of time. And one of the ones that I think is really interesting is using Jwt Authentication. So in this example, I have this edge function that's deployed and it's checking this JWT or JWT token. And essentially there's two different API routes. We have one that is just a normal API route, and then we have another one that's actually using an edge function. So to try to demonstrate this, what I've done is have two different APIs shown below, one that's using edge and one that's using just going to origin. Now, this isn't perfectly realistic because it's not actually doing the full authentication with some provider, but I think it helps to at least illustrate some of this. So ideally, you're going to see the edge responses be a little bit faster. And I'd love to take a look at some of this code and kind of talk through what that looks like. So on the left, inside of this example, we have our pages folder. And the convention that we're using to define how you invoke this logic is called middleware. So inside of our API folder, we have a new file _middleware. And inside of here, we're taking a look at the URL. If it has the parameter of edge, then we can essentially directly respond and handle that authentication without having to do that extra check towards the API route. So then this logic actually runs before the API route logic. Now, this logic, it effectively does a very similar thing. It looks at a cookie, it verifies a token, and then it returns some payload based on that. But the interesting part is when this actually gets deployed on a platform like Vercel, this could get deployed as a function somewhere, and this can get deployed as an edge function. So the difference kind of between a serverless and an edge function here is the edge function is another layer closer to your users.
Yeah, and so this makes a lot of sense to me because when I look at this traditionally, when we try to do this type of logic, we used to use things like Nginx or Apache. We would go find some module and you would go to the centralized system. And as a developer, you would have to know how to edit a Apache config, maybe even restart that server and wire everything up to do this kind of logic, right? So I want to add authentication to this app. Now I got to go hunt for one of these systems that I should go do it at. I think now what we're getting, and if I understand this correctly, as a developer, I can stay within my same application logic and then just add this middleware, not deploy to a backend server, not touch Apache, but just stay in the same flow that I'm already in and just say, look, I have this logic, will never go to the browser. I think that's kind of the key point here. It's going to instead get deployed somewhere where Vercel's platform is going to wire it up automatically, intercept the traffic, and then do all the logic that's in here. And then I just hit save, redeploy my app. And now I have this thing that just sits in the middle without thinking about touching 5 or 6 different places and restarting things. I think that is probably the thing that might blow people's minds in terms of you have this self-deploying thing that knows automatically from convention that it needs to get deployed one layer below the browser and just be available everywhere.
Yeah, and I think building off of this too, it's enabling a new set of developers to take advantage of some of these tools that maybe they had deferred to another part of the team or they thought was outside of the scope of what they could do. And another interesting example of this I can show is Let's say you have some API and you want to do some kind of rate limiting with it. Let me pull this up here.
And as you're showing this, the thing that comes to mind, though, maybe I don't know how we answer this question, but typically one benefit of the centralized world is that I can define these things like rate limits, in one place, and then all applications can just point to my centralized kind of middle, proxy, Nginx or Apache, and I can just handle everything there. What challenges does this present if every developer and every application is kind of embedding this logic and I need to go make a global update to all the components? What's the trade-off being made here?
Yeah, that's really important to talk about because I think we've seen developers want to move closer to the edge. And because their edge compute and logic was decoupled from where they were actually deploying their application, they were two completely separate workflows and pipelines. And because of that, you could often get into instances where your systems got out of sync, essentially. And even on a fundamental level of caching, now you have two caches in the mix. So the closer that we can marry the infrastructure to the code that we're trying to write and define helps developers fall into that success pattern where they can use these primitives and not shoot themselves in the foot, essentially, by putting in logic that is going to ultimately end up in a bad experience.
Is there a way to share some of this logic? Let's say developer A writes the perfect, geo redirect function. And in my mind, coming from my world, I would like to write that once, put it somewhere and give it an endpoint, and then have people just call that as like another API component. Is there an opportunity to do things like reuse logic versus it seems like maybe embedding it in every app that I'm working on?
Yeah, I think that's a fundamental part of what we want to achieve with edge functions and through the abstraction of middleware is empowering developers to bring back some of that flexibility that folks are used to with things like express middleware. So whether I'm doing an authentication check, whether I have this library here for IP blocking in this example, all these things that are going to start to be pretty common use cases for middleware, I want to abstract those out into a reusable package and use them across different projects or make them open source. And the nature of bringing middleware to open source in Next.js and other front-end frameworks is that they'll be able to npm install these packages and integrate them into their existing systems. So the constraint here, and part of the reason why edge functions are fast, is the underlying runtime that we're making. So we're making a trade-off by not exposing the entirety of Node.js APIs and instead constraining the runtime to use standard web APIs like Fetch or Crypto and being built on top of the JavaScript V8 engine. Because of that, we're able to eliminate some of the remaining trade-offs that you had with serverless. So the cold boot problem, connection pooling, and more easily deploy these functions globally. So if I want to abstract this logic for blocking IPs, I can put it in an ES module that's not using any specific node APIs, and then easily install that and share it across my team.
All right, now this starts to make a lot more sense because now that I'm looking at it, this is how we do and think about network configurations, right? There is like a module that does things like IP blocking, and then it's on the developer or the operations team to configure what IPs they would like to have blocked and for what reason. And so it seems like if I were to centralize this into a high-level library, then I could easily just say, hey, what you're really doing with this middleware is deciding how it's being used, like configuration, if you will. And then that module and that code can be reused. So my guess would be if I wanted to centralize that, I would just treat it like any other software package, version it. And then if we want to roll it out everywhere, someone would just do a redeployment and you would pick up all those changes and it will be pushed out across the entire edge.
100%. Yeah. And to take that even further too, like there's so much of this logic that we could be abstracting out to share. Like to further hammer home that point about IP blocking over here, I can essentially enable these developers to put in any IP address they want and, add it to a global configuration of some some list of blocked IPs, whether that's manual or automatic. So maybe you want to manually do this configuration, or maybe in this example on the left, you want to set up a middleware to have an API that automatically rate limits with exceptions around, bearer tokens or some kind of auth token. And if they have that token, then we want to up those rate limits quite a bit because we know that they're a trusted party of using this. And that essentially comes down to a few lines of code, assuming that this right now, while it's in this repo, you could really easily abstract this out into a library, and then it's just a rate limit. And that's the only code that you need.
So one question I have from this, because this is genius. So this looks like what we used to do with things like Lua modules and Nginx. But again, we would have to do it for every route, and it could get super messy, and also was so disconnected from the actual application. The one question that kind of stands out for me here is, where do you put the config? For example, if I do have like 35 IPs that I want to store to check against, I don't see a config file here. Would I actually have to establish some other data source, like a database, or I think you're using Upstash, which is like, I believe, a Redis compatible API that's hosted somewhere else?
Yeah, the great thing about Upstash here is we're using it as a REST API for Redis, and it's globally distributed, deployed across the world. But you bring up a really good point, which is we've given you this abstraction, we've given you the tool, but what about the data layer? How are we going to solve that piece? So right now, from a Vercel perspective, the edge functions on our platform currently don't have an integrated key value storage solution. But that's something that we're actively looking to support to eliminate the need for a developer to go outside of the platform to find a place to store that configuration. Now, over time, we might see that evolve even further, but I think key value is really the first concept for us to nail that is very compatible with use cases for edge functions.
All right, now this makes a lot of sense, because now I think you kind of solved the configuration problem. As I make changes and decisions, either in real time or dynamic, then I now have a place to kind of store the actual output of some of those decisions. And also some of the things like caching layers. If I've already made a decision, the last thing I want to do is recalculate the decision in a small window of time. I guess for me, it's like, what doesn't go into this layer, right? To really understand something, I always think it's important to know when not to use it. Should people be thinking about taking their entire product catalog and stuffing that into a CDN or Edge or something like Upstash?
Yeah, that's a great question. It kind of comes down to where we see the future of web architecture headed. So specifically, if we look at databases, I think we're seeing this new breed of databases that are edge first. So we talked about key value stores, but it could be a SQL-like schema or evolving databases that we already know, like Postgres or MySQL, to run global first. And I think when you ask what doesn't work, we're seeing that a lot of these applications are getting modeled after eventual consistency. So with e-commerce, they might be favoring speed over global consistency. And in my opinion, we're kind of going all in on that model, allowing people to essentially granularly cache things at the edge. Now, what those things are, it might be compute, or it might be actual React components. And we can dive into this a little bit later, but it's still then allowing you to pick back up on the client side and have the full power of JavaScript. So I think that when you look across different industries, e-commerce, but even in finance or other sectors, databases are kind of going global, and combining that with the edge is just trying to make it fast everywhere. Does that mean that we need to move everything to the edge? I would say no, especially if you're trying to do something that has a hard requirement for global consistency. In my opinion, the eventual consistency model just maps better for this type of logic.
But I also think we're thinking about better access to those type of systems, whether it's centralized or distributed across an edge. That comes, I guess, as an implementation detail. If I have the ability to reach these type of systems from this new kind of function framework, then does it matter where it lives, right? I could sign up for a hosted service, and all I'm concerned with is latency to my data. And if they can achieve that by putting my data and replicating it very close, then so be it. So I think maybe that's where we're headed, is just the distributed landscape, similar protocols, and we're cutting down things like latency and some of those challenges by bringing things closer to the compute.
Yeah, the way I like to look at it is I think that hopefully it's a natural transition up the stack for backend developers who are trying to learn more about serverless or edge, because in making the constraint about the limited runtime and not being able to use node APIs inside of an edge function, I feel like in getting rid of some of those trade-offs that they might have previously correlated with serverless and trying to make it fast by default, I think will help them adopt and understand the use cases for a lot of the applications of edge functions or middleware. And then to your point about like where this will grow. So right now with the Vercel platform enabling edge functions, we're already seeing, I think, a rise of this type of edge compute across the industry. And my expectation is just to see this continually rising, not only for compute at the edge, which has been around for a few years now and rising in popularity, but also running your actual application rendering at the edge. So the way I like to think about this is a lot of that sounds kind of like 2000s web, like you just serve a render and you get your page. And there was this transition from let's do everything on the server to let's do everything on the client. And some people fought back about that. Not everyone thought that was the best approach. And now I think we're kind of converging and coming to this happy medium where we say, actually those server people were right, and those client side developers, well, they were also right about some things too. We want to take the benefits of the 2000s web of fast single page or fast server rendered applications and marry that with some of the inventions that single page apps or client side apps gave us with fast navigations through prefetching of routes. You click on a link and it feels instant. It feels like an app. So what I see the edge doing for the future of cloud computing and the future of the web, especially with innovations like React Server Components, is bringing back the server first model and getting quick responses directly from the edge while still remembering the innovations that we made on the client side for interactivity to then hydrate or add more logic after your page loads. And I think
one thing I can think of here is that the networks have gotten so fast, whether we've just made them bigger and closer to where things are happening, that we're almost now at the point where we can treat, there was this saying, we can treat the data center like a computer. But now with these networks so advanced, you can almost treat the internet like a computer itself. And so now the operating system, and now, through this conversation, Vercel just feels more like this operating system for this kind of distributed computer that says, hey, just like on a single server, that some things will get loaded into memory and some things will be paged to disk. Some things run in kernel space, some things run in user space. And sometimes we create these boundaries for security reasons. Sometimes things just don't make sense to run in one place over the other. And I think computing, we've always had this trade-off between security and speed. And you put things in the right place. But I think now what you're doing is trying to blur those lines to say, what if we just treat the whole internet as a computer and we'll just locate things where they need to be in order to satisfy those two concerns. I did learn a lot just from having this conversation. So I think other people that are watching, if they watch the whole thing, asking these kind of questions back and forth, they're like, why are we here now? What does it bring to the table? And even having that code walkthrough, I think was really helpful for people to mentally map what things are happening. But yeah, I think Vercel as an operating system for the internet, I think it just makes it easier to grasp what's happening. You got to just let go. You got to let this thing figure out where things need to be deployed, wire them back up, and own how it works. And that's what kernels do on operating systems.
Yeah, I think developers thought it would be easier to decouple their application from the infrastructure. And I think where we're moving, it's like, but there's actually a lot of trade-offs with that. There's a trade-off with the flexibility of moving your application, but there's also a lot of value in the closer you can marry those two together. And the great thing about Next.js, in my opinion, is that when you deploy Next.js to Vercel, you're making the trade-off to marry those two together, but its core is still open source. So if you decide, I'm done with Vercel, I don't want to pay them any more money, and you say, I'm going to go host Next.js on GCP, you totally can. Because all of these primitives that we're introducing, like middleware, it would just run on a single origin server. So I really like that because it's still bringing value to the entire ecosystem and eventually to other frameworks too. the way we've designed this abstraction on Vercel is that it will work automatically with Next or Svelte or any of these other languages or frameworks just by conforming to our API for how you implement this.
Oh, that's dope. That's going to be good to call out on the docs and when you give people the experience, because some people, I think that is kind of the question we hear when we think about these new platforms. They feel like black boxes, and it reminds people of kind of like lock-in, but it sounds like that's going to be addressed up front in this design.
Yeah, and the way I like to think about it is we're moving to this world where if we truly do build the SDK for the web, people will still have their syntactic sugar and preference of choice, and there's no way to get around that, and that's okay. We should be empowering those developers to make innovations in their own spaces, but we still want to give the same shared Legos and building blocks for creating a great web experience. So when I look at the Vercel platform, we're investing heavily in what we're calling the file system API, which is conform to this file system output, dump it on our operating system, and it will just run globally and use all the features that are possible. And it's so easy then for framework developers. I could go out and build my own framework today, and it could have web vitals analytics, image optimizations, edge functions, serverless functions, CDN caching, just by conforming to some output.
No, it makes sense. I think now that the web may have finally found its operating system.
I love that tagline. I think we're going to steal that. And on our homepage, it's going to say Vercel, the operating system for the web, co-signed by Kelsey Hightower.
There you go.
Well, thank you so much for taking the time to chat today. I really appreciate it. And for those watching, I hope you enjoy the rest of Next.js Conf 2. There'll be lots more content around edge functions.
Thanks for having me.
Thank you.